All right, number 30 from the fall ACP review. A ball is dropped from a height of 6 feet and the return bounce is 82% of the previous height. How far has the ball traveled when it hits the ground for the sixth time? Round the answer to the nearest tenth of a foot. And so here, this problem is a little tricky for one reason. So the ball is dropped from a height of 6 feet. When it hits, it would bounce straight back up. Now, for the sake of making this look easier, instead of making it bounce straight back up, I'm going to make it bounce a little bit to the side. Now, this is going to bounce 82% of the height up. So if we were to measure from this point down, this would be 82% of 6 feet. If that's 6 feet there, this height is 82% of 6. Okay, and so we can go to the calculator and figure out what that would be real quick. So I'm going to add a calculator, and I would do 82%, choose percent here, and you're going to multiply that times 6 feet. And I'm going to do Control Enter to get this as a decimal at 4.92 feet. That means this bounces up a height of 4.92. That up there is 4.92 feet. And that's hard to see. Let me make it a little bigger. 4.92. But here's the deal. It's going to go up and down, as you'll see. Now, as that ball goes down, it goes down another 4.92 feet. And once it hits here, it'll bounce up a second time. And this time, it'll also go up 82%. And when it hits, it'll go up and down again. 82%, and it'll do it again, and it'll keep this up until it bounces for the sixth time. So it hits 1, 2, 3, 4, 5. We got to do it one more time. All bounces up and comes back down. That's 6 bounces. So now we just need to add up how high it's bounced. So I'm going to erase this for a second so we can see it easier. So this went up 6 or down 6 feet, and then when it bounced, it went up 4.92, and here it's gone down another 4.92. This time, it's going to come up some distance. So let's figure out how high this bounces here. I'm going to go over to the calculator, and we're going to do the same thing, 82%, but this time, instead of saying of 6 feet, we'll say a 4.92. So this one's going to bounce up 4.03. I'll just round to the nearest hundredth. 4.03 feet. So when it comes back up here, this is 4.03 feet. And this is also another 4.03 feet. Now, when we come to this one, we can type that in the calculator. And let's see, we'll have one more bounce here, a second, and a third. So we'll do this 3 more times. So to be quick, I'm going to do this. Just copy it and do it 3 more times, and I'll be exact here. So there's once, that would be the second bounce, and we'd have one more after this. Okay, so there's our bounces. So we'll say we have 3.31. We'll go ahead and add that one, 3.31, and that would make this also be another 3.31. And then here, we'd go to get this bounce, and it was, after 3.31, it looks like 2.71. So we'll have 2.71, and this would be another 2.71. And then finally, this would have a height of, what was it? 2.22. And it would come down 2.22. And we could add those up. Now, I did this previously, and so just to save time, we would get 40.4 when you would add all those up. So that would be your answer, is 40.4. Now, you might be thinking, surely there's an easier way of doing this in the calculator. And the answer is there absolutely. What am I doing? 40.4. There is. Now, the calculator can do sums of things that are exactly the same. So it could add up these bounces. It wouldn't add this 6 in. We would have to add that manually because it's not mimicking. It's not a perfect, it doesn't bounce up and down. It just falls there. So here's what we would do. We would take, remember when we do sums, what you do is you use sigma, and n is 1, and you would count how many bounces it would be. Now we have 1, 2, 3, 4, 5. I would put 5 since I only have 5 identical bounces. Okay? Because I only have 5 identical bounces, that's why I'm using that number. And so what happens 5 times? And you use your explicit formula here. So since this is multiplying by 0.82, it's geometric. I'll write that up there. It's geometric since it's multiplying by, or the R is 82%. And so the formula, if you remember, is a sub n equals a sub 1 times your R to the power of n minus 1. We're going to type in the right side to the calculator. So we'd come over here, and A1 is this bounce. So it would be 4.92 times 2. Let's figure out what that is. 4.92 times 2, because it goes up and it goes down. And so that's 9.84. So I take the value 9.84 here. That's my a sub 1. And now I'm going to multiply that by 82% to the power of n minus 1. If I type that in the calculator, that should give me 6 less than this, because I haven't included this part. So let's type that in. And so I'm going to go sigma, which is the button next to 9. N is equal to 1. We had 5 identical bounces. And taking that first term of 9.84 and multiplying it times 82%. Percent's right there next to the G. And we raise this to the power of n minus 1. When I press enter, it gives me 34.4. So 34.4 is what the calculator says this equals. And I should do those squiggly lines there saying it's approximately 34.4. And now what we would do is then we would add the original 6 feet for original drop. And that's how we would come up with 40.4 feet. So whichever way is easiest for you to take it, but this is how you do it. If you just draw the picture, it'll help you out quite a bit.